In the previous video, I described how the Caesium compiler takes code that you write in Caesium and uses it to produce an intermediate representation, which I called the structurized version. I showed a little bit of the structurized version, what the difference is between the structurized version and the grammar equivalent. Specifically, I was looking at function arguments. Which one was it? I think it was parent arguments. I was looking at this type that I used in my example and how it relates to the grammar equivalent of the grammar rule that is used to create the original representation that is closer to the, well, that is essentially exactly the same as the code. I stopped my presentation after describing the kind of the overview of the process by which the intermediate representation is created, and I left you on a cliffhanger on what happens then once you've created all of the structurized version of each file, and you're hoping to now transpile the code into C++. So as a reminder, in the last video we looked at tokenizer, structurizer, primitives, node structs, and grammar. The remaining files are 2cpp, and default includes is literally the header that is put in every generated project, like here. Defaults HPP, this is that file, but in here. So that's not really important. And then the built-ins are just built-in types, essentially either types that I don't want the user to have to implement or types that I need to have some control over to make sense of the program in the way that I hope to be able to. So let's go over some of the basic types that are used during transpilation. So first of all, I have a map of string to vector variables. It's a vector, of course, because you can shadow variables in most programming languages. I'm not sure if I'm going to allow it, but I probably will. Now, in the event where you shadow variables, you just pick the one from the scope that you're currently in. It's that simple, so it would just be the back of the vector. And if I didn't allow shadowing, this would simply be like a map of string to variable info. Now, a variable info is a value category and a type. The type is a little bit complicated. I don't think I really want to go into details, but essentially, if your variable comes from like a normal type, so if you have like an instance of the type dog, like dog d equals blah blah, and then you're looking for the type of d, and it returns a variable info, the meta type of that variable info would be type, and the type here it would point to dog. It's that simple. There are some types such as like transpile, declaration, definition t, transpile t, transpile expression information t. Those are just like used to mark the return types of transpilation functions. So if you have a function that returns a declaration definition t, that means that it's either to parse like a function or a type or something like that, and it has to return a C++ declaration and definition so that you can do stuff like this, right? So this would be like the stuff that's returned. These are like definitions, or declarations rather, and those are the definitions. So what I do, of course, is like for each type, I put the declarations and then I put the definitions. Now, if you actually return transpile t, that's like when you try, for example, to transpile a statement. So if you try to transpile a statement and it returns and it does something illegal, right? Like unexpected, whatever, you just return an unexpected, but otherwise you don't really return like any kind of value or information. You straight up return the string that you're meant to place in the definition that corresponds to that statement, because there's nothing else you can return that matters. This is not quite the case for some other operations. So when you try to transpile an expression, for example, you might think that all you want to return is the representation of the expression in C++, but actually you need to return more. So what I return is an expression information. So it's either going to be a type or a non-type. So if it's a variable, for example, that's a non-type. If it's a type name, that's a type information. It's that simple. So they both have a so this one has meta type and representation. This one, this non-type information, has an expression type, which I do think that the expression type just has a meta type. I think it might be, I wanted to do something here with this and I didn't. I feel like maybe the expression type here could just be meta type, but I'm not going to change it now. I will keep it in mind though, maybe soon. So you can think that they both have a meta type, they both have a representation, but if it's a non-type information, it also has a value category. And it's really important to make this distinction, essentially, that type names do not have value categories, while non-type expressions do. So a value category, it's exactly like in C++. Essentially, when you look at a variable, like, for example, in a piece of code, right? Like if I want the value category of E, well, here it's not a great example because this is a universal reference, but let's go down. So if I ask, for example, for the value category of CPP here, I'm going to get a mutable reference because it's not declared const, it's in the current scope as a variable. So you can take a reference to it, it's a non-const reference. Now, if I ask for the value of the value category of cpp.str, that is not a non-const reference, that is not a reference, that is a value. So a value, as you can see if I hover this, right, this doesn't return like a string reference or like a string r value or whatever. It returns a string value. This is exactly what we mean. So it's kind of like asking, is it something you can reference? Yes or no? And if you can reference it, is it const? That's what you need to answer. So if you can refer, like most cases are going to be variables that are declared in the scope or parameters. So note that, for example, if a parameter is taken by value, when you ask the value of it, you don't get the value, you get a non-const reference. When you ask for, but if it's marked as a const reference, of course, or if it's marked as const, then you get a const reference. So those are like the three categories. So you either have, sorry, let me click that again, right? It's either a reference, a mutable reference, or a value. So there's no, like I know in C++, there's like R value, X value, and I think an X value is an L value that you convert to an R value. We're basically, right, by calling standard move, I believe people say that's an X value. Maybe I'm mixing them up, but I feel like that's correct. So it's like a fake R value. I don't have that in my language because move is implemented from the language perspective, not library. So I don't actually think though that the C++ compiler knows about X values. But my compiler would not have to know about X values essentially. So let me go back. So yeah, when you ask to transpile an expression, you get one of these. And I do think that when you transpile a type name, that is not what you get. So let me just go check. Transpile type name. Yeah, you see, so for a type name, the result is transpile T actually. So that is quite strange, but I believe that the thing is, you can call the only context in which you want to transpile a type name and get a type information is in a place in the code where the expression that you're looking at may be a type name. But yeah, so what I'm trying to say is that 99% of the time when you ask for an expression information, you get a non-type information. But if the expression is built using a type name, then at some point you'd have a type information in there. So for example, there are construct expressions, right? So for example, if you have like int 1, then this is an expression, but this part of the expression is a type name. But I do think that this is always a type name. I don't think that's a great example. I think one better example is if you have some type here, type with a template argument. This argument could be either a type, right? Like could be like int, but it could also be like a non-type template argument. So when you're trying to get the type of this thing, you don't know whether it's a type or a type name. And so you get back an expression information. And most of the time, you require it to return a non-type information. But sometimes it makes sense, like in this example, that would return a type information. So it can be tricky, but in 99% of the code that I write, I do something like this. Like I check that it holds that. If it doesn't, it's just not implemented. That's just an error, and I need to return an error thing, but for now I just throw. So all of these throws in my code, it means not yet implemented. Now, let me go see. Did I cover this? I covered that, yes. So those are the types that are used for transpiling. I am missing the transpilation state. I don't think I'm going to go over the namespace. Copy namespace, okay. Yeah. So as you can see, most of the functions, right, they take a, they take a transpilation state with indent by value. And the transpilation state with indent is something here. It has a reference to a state, and it has an indent. It doesn't have a copy constructor. It's deleted because you have a reference member variable, and you never actually copy this. You always either call dot indented or unindented if you want to create a new one, and this copies the reference and changes the indent. So let me look for like an example of indented would be probably when you're transpiling a function. Right, so you're transpiling a function, you have a certain indent in your state. The statements, you pass state.indented so that they are indented by 1, right? By 1 more than the function. It's that simple. Now, the reference to this transpilation state, whenever you're transpiling, basically you try to mark the things that you have encountered that should end up in the result. Transpilation only goes through main. I get the main transpilation result, which is like a declaration definition, just for main. And the other thing that transpile main does is it modifies the state. Now that's going to add all of the types that should be transpiled, all of the enums that should be transpiled, all of the interfaces that should be transpiled, all of the functions that should be transpiled, and then for each of those, they're put into like declaration, definition, and then CPP gets both of them. And then you get your resulting file from that. I think I will stop it here and then make another video where I go over maybe some implementation details of some of these functions. That sounds about right.